Hello, everybody. Today we have this function f of x equals x squared plus 4 in parentheses to the 2 times in parentheses x minus 5 parentheses to the 4. And we're going to do each part that's listed here, and then maybe some more. So let's first start with a part, list each real zero and its multiplicity. To get the real zero, let's just use symbollab.com. Okay, now to find the zeros of a function, we take the function out and set it equal to 0. So in this case, to find the zeros of f of x equals x squared plus 4 in parentheses to the 2 times x minus 5 in parentheses to the 4, we want to solve x squared plus 4 in parentheses to the 2 times x minus 5 in parentheses to the 4 equals 0. And to make sure that Symbollab knows what we're doing, let's just put the word solve just to be safe. So let's solve x squared plus 4 parentheses to the 2 times x minus 5 parentheses to the 4 equals 0. All right, we'll click go. And we get the zeros of x equals 2i, x equals negative 2i, and x equals 5. And let's see how it does it. So what it does, it takes each factor and sets it equal to 0. So the first factor is x squared plus 4, and we set it equal to 0 and solve for x. So when we solve for x, we get 2i and negative 2i. And then it took the next factor, x minus 5, and set it equals 0. So when you solve for x, you get x equals 5. Now, according to the problem, we just want the real zeros. So 2i and negative 2i are imaginary zeros. So we don't want those. So all we need is the real zero. So let's disregard the 2i and negative 2i and concentrate on the real zero of 5. So there's only one real zero, which is 5. So that's the answer to the A part. But now we also need its multiplicity. So to get the multiplicity, we look at the exponent that's on that particular factor. So 5 comes from the factor of x minus 5, and we look at the exponent, which is 4. And so we say that the multiplicity of the 0 of 5 is 4. And that's the A part. B part says to determine whether the graph crosses or touches the x-axis at each x-intercept. So to do this visually, let's look at the graph of the function. And we have the graph right here. We have x plus 4 parentheses to the 2 times x minus 5 parentheses to the 4. And it's right here. And here's the, now the thing to know is that the zeros are synonymous with the x-intercepts. So earlier we had the zeros of 2i and negative 2i. So since those were imaginary, those do not show up on the graph at all. So the only things that show up on the graph are when the zeros are real. And so we had a real zero of 5 from the A part, and that corresponds to an x-intercept of 5, which is right here. And according to B part, we want to know whether it crosses or touches this 5, 0, or 5. And it looks like it just goes up and touches it, and then it goes back up. So it doesn't really cross the 5 at all. So we'll say it touches. Okay, now how do we mathematically know whether it crosses or touches? Well, here's some information right here. So the graph crosses the x-axis when the x-intercept has odd multiplicity, and the graph touches the x-axis when the x-intercept has even multiplicity. Well, here we know that the multiplicity is 4, and 4 is even, and so that's why it touches rather than crosses. So we can go on and say touches at 5 because the multiplicity is 4, and 4 is even. All right, we have another part to this problem they want to do, but we'll do that in the next video. So in the meantime, that's how to find the zeros of a function, its multiplicity, and determine whether the graph crosses or touches the x-intercept on that graph.